This conference will now be recorded.
So what we had discussed yesterday, I've shared all the recording for you guys. That's all the recordings from the beginning. And so what do you learn yesterday? What we have discussed yesterday? What are the components we have discussed yesterday?
Router, firewall, IPS, and proxy.
Yeah, it's a router and firewall.
Okay. So what is the router?
Yeah, it's a network device switching packet between two networks.
Okay. So apart from any other functionalities?
Packet filtering.
Packet filtering.
Packet filtering.
Okay. Any other?
It provides the best path to reach the packet.
Okay. So who is the vendors for the routers? Who will provide?
Cisco.
Cisco, Juniper.
Juniper.
The firewall?
The same Cisco, Juniper, Palo Alto, checkpoint.
Okay. Cisco also. Cisco,
Yeah.
Palo Alto, Juniper.
SRX.
Juniper. Okay, yeah, these are the major means. So what is the firewall? What firewall will do?
It monitors and controls incoming and outgoing network traffics. Controlling traffic.
What is the stateful inspection?
Tracking of all communication.
Tracking every connection, incoming and outgoing network connections.
What is the proxy server will do? Proxy device?
It bypasses the network traffic.
Bypass. Whenever you try to access any of the websites, so first the request will be going to the proxy server. The proxy server will search, will stop the connection there, and then initiate a new connection. So before initiating a new connection, it search this database, the proxies database, and is that particular website is allowed to access or not. So it checks first. So before going to internet itself, so it checks, and then a proxy server will initiate a new connection to the before that it checks its own database whether this site is allowed or not. So some of the websites, the proxy server admins will not allow. So they will not allow. So those cases, so by default, the proxy will stop the connection, will stop into the internet. So you will get an error. When you are trying to access, you will get an error saying some proxy server is unable to, proxy server is stopping you to reach the internet. So that's how the proxy works. So what about the IPS?
IPS will check for a previous attack signature, that is payload. If it is malicious, it won't be allowing. If it is new, it will be checking for any it is malicious or not, and if it is not, means it will be allowed.
Okay. Yeah. So IPS intrusion prevention system. So intrusion means something that is gonna do bad for the net. That is the intrusion. Intrusion is it's even yeah, even we can call it as a, even it is a intruder. Even attacker also we can call it as a intruder. So it's gonna do something bad for your network. So intrusion means something malicious activity. So what the intrusion prevention system device will do in preventing the intruder activity. Intruder is, who is the intruder? Who is gonna do something bad for your network. That is the, even we can call it as an attacker, hacker, intruder. Uh, so so the same, everything is same. Okay, fine. Uh, how does IPS works? Let's say, so IPS have its own intelligence. So let's say IPS is provided, Cisco is providing IPS. So what the IPS Cisco IPS will do? So their devices all are connected to the cloud. So what they will do is, they will, if there is some attack is happening in the globe, anywhere in the globe. So what they will do? They will upload their signatures. Let's say the malware behavior is, this is how the malware behavior. So this is how the malware pattern. So according to that, they will develop the signatures and then they will upload it in their databases. So what happens? It's centralized, means each and every network. Let's say I am using a Cisco IPS from my network. Okay. So what happened? My Cisco IP, my Cisco device IPS is connected to the cloud, means Cisco's threat intel. So it is connected to the Cisco's threat intel. If anything is updated by the Cisco company, so automatically my database also will be updated with the latest malware signatures and patterns. Okay. So the signature itself we can call it as a, the signatures will be developed based on a certain patterns of malware. If the same malware attack is coming on my network, so my device is able to detect. Correct. So I told one example. So let's say the one person is a bad guy. So he already knows. He already in the bold. Everybody knows. So this guy attacked something he did, some attack he did, and in the bold everybody knows now because of via some media channels. So because of some media channels, he knows everybody. What others knows, he's a bad guy and he will do something. So everybody in the world knows. When that guy comes, when that guy comes into some other country or some other place in the world, so that people will not allow him. That people will not allow him to in their country or whatever, because they already know that this guy is a bad guy. So this is how even the IPS will work on the same pattern. So if that is a bad means, so everybody, even not only Cisco, so every IPS vendors will update their database so that the same attacker will not come. The same attacker or same intruder will not do the same attack on your network because the device is blocking. Okay. So the difference between IPS and IDS is same. So IPS will block the traffic. Whatever the attacker is coming means, it will stop the attacker activity, reset the connection itself, stop the connection itself. Okay, that specific data traffic has been blocked from IPS. IDS is, it will detect. It doesn't do any action. Okay, it will not perform any action, but it just give an alert. Give an alert who is monitoring by IDS. So IDS IPS have us again admins. So they will be monitoring, they will be updating the signatures, they will be monitoring the IPS device continuously. So that's whenever they got an alert detected, they detected something. So once they detected something means automatically they will start investigating on it. So mostly we will go for IPS. Nowadays, so firewall, even firewall, and IPS are inbuilt. So that's why we call it as a next generation firewall. So right now, if you see the current currently there is no IPS IDS separately coming. So it is inbuilt with the firewall. The IPS is inbuilt with the firewalls. So that is called as a next generation firewalls. So Palo Alto is a next generation firewall. So if you see Palo Alto, if you're logging into the Palo Alto firewall, which is having a both the firewall functionality. One tab you can see firewall, and another tab you can another option you can see as a IPS traffic. Both the IPS traffic and network traffic, both layer 3 traffic and layer 2 traffic, layer 3, 4, and 2. These 3 layers traffic you can see in next generation firewalls. Okay, so the best example for next generation firewall is Palo Alto, Panorama Palo Alto firewall. So I don't think so. If you see the old customers or but nowadays everybody is migrating to next generation firewall. So that's the difference. If somebody asks, so what is the difference between traditional firewalls and the next generation firewalls? So the difference is the next generation firewalls are inbuilt with the IPS. So they are inbuilt with IPS. So normal firewalls not a inbuilt. They just monitor layer 3 and layer 4 traffic. But next generation firewalls monitor both the level 2, level 3, level 4 network, and it also see the data traffic. Sorry, payload as well. Looking to the payload as well. That is an IPS and IDS. So, one just again. So IPS can works in two different modes. IPS can works in two different modes. The one mode is inline mode, and the second one is image-based mode. Inline and image-based. So what happens? Let's say this is a device example. the IPS, and here is a some router or firewall is there, something firewall is there, example, and here is in inline mode, the IPS will be placed in a in between a IPS or IDS, whatever. Should be placed directly into the data traffic. Okay, let's say here is a complete network. This is the all endpoints, everything is there. Okay, all computer machines. So if you are placing the IPS in between your network, that means directly into your network, that is a inline mode. In a promiscuous mode, what we are doing is, let's say here is a firewall, and this is the internet, and this is as usual some proxy and switch and then devices. So here what happens, the copy of data, the copy of traffic will be passed to the switch, sorry, IPS. Okay, the IPS will analyze here and give an alert to do the action. Okay, so if it is blocking means, so it will stop here itself. So here intimate to the here itself it will block. So if it is an inline mode, so if there is a malicious traffic, it will block here itself. Here it will, if there is something wrong, it will send, it will initiate, it will ask here itself to block the traffic. Got it? So, but we are not using this one. So whenever the client, any of the client or any of the client network, so 99% of all IPS are placed inline. And again, this is outdated. This is a 3-4 years back. This is a 3-4 years back deployment. But now we have the next generation firewall. Okay, the next generation firewall is inbuilt. So we don't have a separate IPS and we are not monitoring separately IPS. This is the outdated version. This is the outdated one, but this is just for your information. So if usually the IPS can be operated in inline and permissionless mode. So inline it will be there directly into the in the traffic in between a network, and it monitors the traffic directly from traffic. But permissionless mode, it's a different one. So copy of data has been given to the IPS, and then the IPS will analyze and then do the action. So blocking or alert. That's how that's the difference between a inline and permissionless mode. This is just for your information. If somebody asks, so how does inline and permissionless mode works? Inline is a in between, it comes between directly the traffic will be forwarded to the IPS. Permissionless mode, copy of traffic will be given to the IPS for analysis. How does IPS works? Again, so here the device is there, IPS. What happened? IPS having a centralized database. So we can call it as this one also IPS sensor. And IPS, they have a IPS centralized database management. Centralized signatures database. IPS database having a set of signatures. Let's say this is a real world scenario how how the sensors are placed in a network. Let's say my company is there. My company is ABC company, right? So my company is there in a Hyderabad, and ABC company in Bangalore. So ABC, this is the Bangalore, and here is a Chennai, and this is the Delhi. Example. So ABC company. So every company have a IPS sensors. So every company is connected to the internet, right? So internet, the internet data, internet traffic is coming to your network. Means it is coming via IPS, firewall, everything. So all IPS, these are all called as the IPS sensors. So all IPS sensors. So they are the sensors. What they will do, they will connect to one centralized database, IPS database. So the database having a signatures, all the set of signatures, and every time when the traffic comes, the IPS will be compared with the IPS database. Okay, let's say some pattern called as a ABC pattern came. Okay, malware, some pattern database, the payload pattern. It verifies this ABC pattern with an IPS database. Okay, here also it comes with some pattern like XYZ. It verifies with the IPS database. If it is matches, the data it matches with the IPS database, pattern is matches with the IPS database, then the IPS sensor will block the traffic. That's how the IPS works. So what is the next device? So proxy we have discussed. Next device is switch. So we already discussed a router. Router is connecting a two different networks. Switch is connecting of, it established a communication between two different devices, two different hosts within the network. Within a network. Let's say, so if I want to communicate 4 devices, so I go for a switch. Okay. Another example, let's say I'm having a router in my home. So my router home, that's a wide one example. Wide one. It's not a wireless, it's a wide one. So I can connect maximum 2 to 3 ports. So not more than that. So that's the reason. If you any of the organization, if you see any of the organization, so they have a bunch of computers, right? They have a bunch of hosts. They have a bunch of systems in there. Let's say if you see of any of the BPOs, they have they all are having the desktops. So all the desktops are connected via LAN cable. So how does they communicate each other? So they have to communicate all the systems connected together, and they have to communicate. So how does it possible? With the help of switch. What the switch will do is, this is the switch. So in the switch, this system want to communicate this system. So how does it communicate? So the first, it is having the port numbers. So when this is the port number, this is the P1 port number, and this is the P3 port, example, P3, and here is another host, that's a P2, and here is another host, that is connected to P4 port number. Switch have the port numbers. Okay, switch have the port numbers. So whenever you want to communicate P1 to P3, okay, The switch have the MAC table. It says that port number P1 having a XYZ MAC address. Port number P2 MAC address ABC. P3 something like C, D, E. So P4 G, H, I. Example. So the MAC address. This is a port number and their MAC address. Okay. If the device want to communicate, the device want to communicate a P3 port, okay, from P1 to P3. So the first request will be go to the switch. Okay, the switch will see the MAC address. Okay, so destination source MAC address is something. So let's say P1 want to communicate with the P3 example. So what is the P1 MAC? XYZ. That is the source MAC address. So which one it is one destination MAC means where P1 want to communicate. P3. What is the MAC address? CDE. Okay, it is having the MAC address table, and that MAC address is connected to which port number? It is connected to port number. So first, when the data or when the frame comes to switch, so it search for which MAC address it is trying to connect. This host is trying to connect which host and the MAC address. So it matches with this MAC address, ABC MAC, let's say CDE MAC address. So okay, CDE MAC address belongs to which port? Belongs to which port? It sees the CAM table. Oh yeah, it belongs to it connected to the port number 3. Okay, then forward that frame to port number 3. Got it? Confusions? Any confusion here? You want me to explain again?
Yes.
Switch. What is the switch contains? Switch contains, this is called as a CAM table or MAC table. So what it contains? So switch having the ports. This is a P1 port and this is the P2 port. This is the P3 and this is the P4. So like that, a lot of port numbers they have. Okay. So now P1, it is connected to the host is connected to the port number 1 switch. Switch is a physical device. So P1 is connected to this port number is connected to host X. This is the host name. Okay, X example. Okay, this is now it is trying this host is trying to communicate P4. Okay, the P4 MAC address is and the host and the MAC address is something like this. MAC address is something like X. This MAC address is something like A, B, C. So now tell me, what is the X? What is the P1? Who is connected to the P1? Who is connected to the port number 1?
X is connected to the port number 1.
X, Y, Z is a MAC address of so port
X.
number and the MAC address. The CAM table contains the port number and MAC address. And who is the P4? Who is connected to the port number 4?
ABC.
ADC.
Like that. Everybody. And P3. P3 is connected. Who is connected to P3? Something like DEF. So DEF. Now the request comes from the
P1.
packet. Sorry, it's not a packet. It's a. So when you're talking to the switch, you have to talk the frame.
4.
The frame contains a MAC address Ethernet frame. Okay, when it receives the port number P1, what to communicate before means it sends a frame to switch. It is asking that I want to communicate with the P4. Okay, now it searches for them and it also gives the MAC address. Got it? So as I told earlier, so how a device get the MAC address, that is also I told. So every system having their peers, their every system contains their MAC table. Whoever connected is earlier. Okay, the MAC table, it stores the MAC table. Okay. Now switch is trying to communicate. Sorry, this host P4. Raju, can you mute yourself?
Yes, sir.
So P1 is trying to communicate a P4. So what happens? The switch receives the frame and it is having the MAC address. Okay, then who is the destination MAC address? This host P4 MAC address. The switch have. Sorry, even switch have, and then even mission also have the MAC. So it asking to I want to communicate the P4 this DEF MAC address. So the DEF MAC address, the switch contains the port number. So the switch will take the frame from P1 and it will be given to P4 port. Who is connected to the P4 port? ABC MAC address of device. Got it? So P1 is want to communicate P4. So P1 want to communicate P4 means P1 need port number. This is a port number P1. This is a port number 4. Who is connected to the port number 4? Sorry, P1 port number 1 X is connected, and port number 4 is connected with the Y. Okay, X host and Y host. Okay, what is the MAC address? ABC. Sorry, this one is XYZ. Okay, and this is a ABC. Now X want to communicate with the Y. So what it will do? The request will go to the switch. Switch have the port numbers and MAC address. This one. So automatically it will be forwarded based on the MAC address. It will be forwarded to the correct port number. That's how the switch works.
Connection will be happen through MAC address or port numbers.
See, MAC address, it contains a MAC address table. The switch have the MAC address.
Switch
table.
will be containing. If
Yeah.
request is sending from the P1, switch will be seeing for a MAC address or a port number.
Switch will not see. Switch will see the port number. Switch will see the MAC address. So which MAC address it is?
MAC address.
Because host doesn't know which port is connected. Host doesn't know the destination host is connected to which port number. Okay, so the switch will decide which port it has to forward the frame. which port it has to forward. So based on the MAC address, it decides which port it has to be forwarded.
Okay.
Let's say another case. Okay, fine. So how does understand how does switch works? So a switch in simple word we can say as the switch connects and it provides a connectivity between two different hosts within the network. Within the network. So in order to the two systems are trying to communicate, two systems will communicate with the help of switch, which have a complete timetable which contains the MAC address and their port numbers, everything. Okay, 1 second. Okay. Any questions here? Kirtana, any questions you have here?
Yes, for example, like if switch consist of lots, I mean, like port 1, port 2, port 3, port 4. If in that, if X need to communicate with Y, then with the help of the MAC table of the switch, it gets the MAC address of the Y, and then it will switch will connect X and Y. Am I correct?
Correct. Correct. Yeah, with the port number, you say correct. So let's say X want to communicate with the Y. So X contains the X already have the MAC address of Y. All right. X already have the MAC address because they already communicated earlier, or they whenever any host is whenever any host connected to the network. So automatically what happens? The MAC address will be MAC address, even the MAC address will be there, or as I said, the ARP resolution, right? So address resolution protocol. So it does the same mechanism. So it broadcasts the first time. Okay, once the system learns the MAC address, okay, it stores that MAC address in the CAN table of all the hosts. Even I showed you in a command prompt that how many systems are connected, how many hosts and their MAC addresses stored in a. I showed you in my command prompt that the MAC table. My See, this is how when you see command prompt, so for any of the device, you can see here the host, so the IP address of the device and the MAC table. So every device contains a MAC table. So whenever a device B, whenever any of the device want to communicate, so it goes with the MAC address to the switch. The switch knows already. So this host is trying to communicate this MAC. So and this MAC is connected to which port number. So that's what the switch will look up that, will look up the table and which port it is connected. So that just switch the frame to that specific port number. Some command is there. I am not remember the command. So even my system also I can see. So what are the hosts? How many systems are connected? Systems and their MAC addresses in my MAC table. Okay, fine. So what was the next? Next one is, so every mission again. So every mission is having the antivirus. So every mission, that is another security solution. So that's another security solution which provides the security on device level. So till now we have seen the security like a firewall, IPS, IDS, proxy. So these are the network level, they will provide the security, these devices. But the host level, the every host is installed with the endpoint security. That is the, we can call it, previously we called it as a AV, antivirus solutions. But now people will not call it as an antivirus. We should call it as a EDR, endpoint detection and response. Got it? So now nobody will call it as this is an antivirus, but non-technical people will used to say like, who doesn't know proper these things. They used to call it as the system is installed antivirus or not. But we used to call it as, the security people will call it as EDR solutions. So endpoint detection and response. So what the endpoint detection and response will do, or antivirus will do, they will just what the EDR solutions will do or AD will do. So EDR is sitting every host. This is the one server. So it keeps track of every activity. Keep track of every activity. Okay. Tracking of every activity. So what activities? So let's say the server was creating the server was is trying to communicate some of the external IPs, and that activity it will keep what it is doing, and if there is some software is installed, so that software details also it stores in the database. Okay, and if there is something is if that process software is executed, what are the process changes is happened in the system level, so what are the registries in the system, what are the file systems, so is there any changes in the file systems, so everything will be monitored. There is a agent, endpoint AV agent or antivirus agent or EDR agent, whatever it is. So it was there in the server. It is the agent is installed in the server. It keeps track, keeps monitoring your server activity. Server activity. It's like what we can say. It's it's like a spy. Spy. What it is? What the spy will do? The spy will continuously monitor. Will continuously monitor what you want doing. Okay, the same way here also. So when spy is there in your home, so what he will do? He will continuously monitor what you are doing. Got it? So the endpoint detection and response, what it does. So is there any malicious software or anything? Is there any software which is unauthorized, unwanted? So it automatically detect. It detects couple of. So again, how does it detect this endpoint EDR? How does it detect? Based on the same, like as I said, there is a signature based. The malware it is having all the malwares and their patterns. So every time the agent will check with this signature database, and if something is matches, it gives an alert, or sometimes it will block or quarantine the thread. So quarantine in the sense, so it just it doesn't execute whatever if the endpoint detection EDR or AV finds a threat. Let's say it finds some virus in the system. So what it will do immediately? It will quarantine the virus. Quarantine in the sense it doesn't execute the file. It will not allow to execute the file. That is what it does. And even some cases, some of the malware will directly remove the thread from the system. It will delete the file itself from the system. And some cases it will detect, okay, but it will not block, or it will not, doesn't have the capability to block that specific threat. Means it just give a alarm to the security guy, so that the security guy will react accordingly, and then he will go to the system. The security administrator will take the system, and then he will find out the thread, and so he will remove the thread from the. So you will get every details from the endpoint detection. So what file it is, which path it is located in your host, which which place it is there, and what kind of threat it is, classification of threat. So everything it gives. So according to the, if it is not quarantine, so you have to take an action. Otherwise, it will impact. It will compromise your device. Got it? So that is what the EDR solutions. So it's purely based, it works purely based on signatures and some patterns. So some malware patterns based on a pattern. If the specific pattern matches, it gives an alert. It may be a true positive, or it may be an actual. It may be an actual attack, or it may not be actual attack. So you have to verify. You have to verify whether this is actual. Some software or some legitimate activities also. It match with the malware pattern, so it gives an alert. But it's not a malware activity. It may be some normal user activity. That is also sometimes detected by the AV. So you have to verify, and you have to take action accordingly. Okay. So what the EDR will do? Tracking of everything, what your monitoring of your end device, monitoring of your computer, so what it is doing. So if there was unwanted software or unauthorized software or unwanted things which is not standardized. So everything, let's say if I'm opening my computer and I'm connecting to my internet, so and I'm accessing from the some content from the Google. So that's everything is a normal process. Okay, other than if I am using something like some other Tor browser, and I'm communicating to some other anonymous browser, so that's something wrong. So that's not a standard process. That is not a usual process. So those cases, those unusual activities will be detected and reporting to the security administrators. Okay, that's a EDR or AV. Okay, yeah, that's one. I think I have covered all the network devices. So, so we will be starting from the next session, next class. We will be starting with the actual security concepts. So we will. So till now we discussed the network components, network security components. Then the next class we'll be going to discuss the actual security concepts. Will be going to the security concepts. So why we need a security professionals, why we need an information security. So how we gonna do secure our network. So what are the major threats for any of the customers? And so as we have the cyber concern where the attacker point of view, how the attacker can attack, how the attacker can get into your network. So what he will do, so how he can steal the data. So with the help of the security framework called as cyber encryption, we will discuss with that. At the same time, when the attack is happened defender, as a defender, so you're working for one company, you're a defender. How you gonna protect your network? Okay, what are the incident response plan you have to follow? So there was a standard incident response plan. So we have to follow that. So how does it work? That is also going to discuss, and the different kinds of attacks. So like we have I think 7 to 8 or we'll discuss 7 to 8 or yeah 10 plus 10 plus kinds of different kinds of attacks we will discuss, like DDoS, start from DDoS, DNS cache, DNS amplification attacks, DNS cache poisoning, and a lot of other, so lot, MAC, even MAC IP spoofing, and a lot of examples we'll discuss, and we will see one real-time attack, one real attack. And if possible, I'll show with these tomorrow, the next class. If I'll try to show that the Wireshark, how the packet looks, what is the IP address, IP header, TCP header, everything I will show real time, possibly next class. So anybody tried Wireshark? Anybody used the Wireshark?
No,
Okay. So
no.
do you know what is the Wireshark?
No.
So Wireshark is a packet capturing tool. Let's say I'm communicating to Google, so it generates a packets, right? So let's say first I'm trying to connect to Google. So what it does, it performs the TCP three-way handshake, right? So the performing that TCP three-way handshake also we will see by capturing the packets. So the packet, how the packet looks. When you open up the packet, what is there in the packet? So TCP header, IP address, source IP address, destination IP address. So everything we can see in the Wireshark. So we are talking a packet, right? So that packet will see in the real time with the help of packet sniffing tool called as a Wireshark. Okay, I'll try to show by the next session. And yeah, I think the switch is still confusion, I guess, you guys. That's how I see. But anyway, I'll show you with a couple of figures how does it works, and the next time I'll show you with the figures. I'll get it from the internet and I'll show you with the figures. Okay, so then you can get a clarity. Fine. That's all about today class. And so I have shared all the recording sessions. Go through that. If you have any doubts, you can go through it. And, you will get an idea. So Rajiv, I think just go through the videos, last videos, so it gives better understanding. Okay, and if you have any questions, you can reach out to me so that I will help.
Yes, sir.